All right, here are solutions to perfect problem 5 for Math 243. So we have a random sample, 55 golfers, 40 of them hit 0 holes in one, 15 of them hit exactly 1 hole in one. So in part A, calculate, so maybe A. Calculate the proportion of golfers that have hit a hole, okay. P hat equals 15 divided by 55. Right, you got 55 golfers, 15 of them hit a hole in one. So we can reduce this. This is 3/11ths, or what, 2 points, I think it's 0.27, 0.27 repeating. Maybe I'll just leave it like this. So use this to create a 90% confidence interval. Okay, so for a confidence interval, we need a few things. We need to know what is the critical. Okay, so our point estimate. So our point estimate will be, so where should I write this? Confidence interval equals our point estimate, our best guess, which is P hat. Maybe I'll write that. And then to that you want to add or subtract what you usually denote as Z star, kind of your critical value. We'll figure that out in just a minute. Times the standard deviation of P hat, which is given by, well, I'll write it this way, P times 1 minus P divided by N. And so P hat is our sample proportion. P is our population proportion. We don't know this, so we use P hat to estimate it. So what I'm saying is we'll get 3/11ths plus or minus, let's see, Z star, you want to look that up on your Z table. The number corresponding with the 90% confidence interval is 1.645. And you want to multiply that by the square root of 3/11ths times 1 minus 3/11ths, which is 8/11ths, divided by N, which is 55. And if you plug all that into a calculator, you get 3/11ths plus or minus 1.645 times 0.06. I'll write a bunch of decimals, probably more than you will. Maybe 0.005, something like that. Okay, and then you can figure out what this is. Again, put it into a calculator. You calculate it all out. You get this. Our margin of error here is 0.09879. And if you do 3/11ths plus or minus that number, you get here, which I guess you could say is 17.4% approximately to 37.2%. 37.2%. So something like that. Good estimate for our confidence interval. So in part B, it asks you to do this again to kind of replicate this. Okay, so what I was going for on this problem was just to show that these proportions are no different than if you had calculated this out kind of the long way, the way we've been doing things. The only thing that's slightly different is they use an estimation of sigma instead of S. I don't want to get too technical, but so maybe I'll just leave it at that. We use S, which is an unbiased estimator for our sample standard deviation. But the population standard deviation is slightly different. They're almost the same. You get them both when you do one variable statistics. But if we use this one instead of this one, we'll get this exact same answer. So what I mean by that is we can put this information here into a calculator. So we got 40 zeros. So you go kind of edit, list. So I guess this is stat, edit, list, and then kind of put in a whole bunch of zeros. And then put in your ones. You got 40 of these guys, and you got 15 of these guys. And if you put all that in, the numbers that you'll get out of this are, let's see, you'll get X bar, and you'll get sigma. And let's see, stat, calc, one variable statistics, and then tell it what list you put your information in, and you'll get x bar is 0.2727. You get this same x bar, this 3/11. Maybe I'll write it 0.27 repeating, since that's what you'd get out of your calculator, which is 3/11. And if you use sigma, you get 0.44536. So what we want to do is our confidence interval is x bar plus or minus z star times sigma over the square root of n. So we get 3/11 plus or minus 1.645, the critical value of z, which we saw before, times this 0.44536 divided by this square root of, what do we have, 55 golfers? And if you do that, what you end up with is kind of exactly what we had up here, 3/11 plus or minus 0.09879, which is equal to 0.17394 all the way up to 0.37151. Maybe I'll write or 17.4% to 37.2% again. So not just approximately, not just close to each other, they're identical if we're just do this one thing a little bit careful using sigma instead of s. But this is just for this one perfect problem, just to illustrate this point. Going forward, everything else we will do, we'll use s. So hopefully that shows stuff and doesn't confuse people. But that's the end of this perfect problem.